Hello friends, good evening to all of you. Here I am going to discuss the vector and its rectangular components. But little I have changed my style of teaching, and I am here going to solve your problems that I have given you already in your classroom. The difference from other method, that the force will be resolved in ij unit vectors. This is two-dimensional ij unit vectors, and the question is, a vector has component along x-axis equal to 25 unit and along the y-axis along equal to 60 units. This problem you can see on your screen. Find the magnitude and direction of the vector. So what we are doing, we are taking resultant vector. So can we not have any other method? Yes, we can have any other method also. So we will try to write this question it into rectangular components, that is in unit vector components, I unit vector and j unit vector, right? So you can see on the board, this is your question. So you are given 60 units. You can see on the screen 60 units on y-axis, and here you can see 25 units on x-axis. You can see very clearly this this light indicating 25 unit on x-axis. Fine. So what we have to do, we have to take the resultant or the magnitude and the direction of this vector. So let we assume that this is this vector a we have to find out, and we can write it in direct form. How? Okay, fine. 25 units in along x-axis. So what we can write, let a be any vector. We can write a be any vector, and this 25 unit, it means this can be written as 25i, 25 units on x-axis. And second thing is 60 units on y-axis. So this is your 60 units, this is 60 units. So 60 units, so we can write 60j. So now this a vector we have written, so it is taking no time, taking no time, very quickly we can write in its vector form, right? So now if you are having a vector, a vector is equal to 25i and plus 60j, so I think you can find out the magnitude. So a vector, magnitude of a vector will be equal to under root 25 square plus 60 square. So this on solution, or after solving this your number under root 9850, we are getting 65 unit. So magnitude of a is 65 unit. This a has got 65 unit. So on diagram we can say that this is the magnitude, this line is indicating the magnitude of your vector. Fine, the magnitude of your vector. So this line is indicating the magnitude of vector. So what is the length of this vector? So length of this vector is 65 units. This 65 units is the length of the vector. What will be the direction? So we can take theta angle will give you the direction, right? From the vector definition, we know that x-axis means theta, direction, the angle will be in between resultant and one of the vector. So this a vector is resultant, so this theta, so tan theta, we are taking tan theta will be equal to base and height, right? So tan theta will be equal to height upon base. What is the formula for tan theta? So tan theta is equal to height, this 60 upon base, this is 25. So we are getting tan theta is equal to 60 by 25 here. So theta will be equal to tan inverse 60 by 25. This is our direction. So quite interestingly, we can say that in no time you can find the resultant and magnitude of the vector, right? These problems I have taken from SC Verma. SC Verma, the concept and the method is different there, but I have tried to solve, because we are getting a number of problems where we have to write the vector in no time, right? In no time, and in rectangular component, so that we can find its unit vector and its direction very easily. So now I am coming on the second second problem. This is your second problem, and Find the resultant of the three vectors. You are given by three vectors. You know, this vector 5 units is one vector, this is 3 meter is another vector, and this is 2 meter. 2 meter is third vector. So you are provided by 5, 3 and 2. These are three vectors. You can see on your board. Fine. So we can write we can write its vector in one shot. So what we are going to write, this 5 is inclined at 37 degree. So try to take its x component and y component. It means I direction and j direction. So what will be its I direction? This I direction will be equal to 5 cos 37. How? So cos 37 degree equal to base upon hypotenuse. So this is the base, this is the base and hypotenuse is 5. This 5 is hypotenuse. So cos theta will be equal to base upon hypotenuse. So what will be base? Base will be equal to hypotenuse time cos 37 degree. So this is base. It means you are getting I component. Similarly you can get j component in y direction. So 5 has got another component in y axis, y axis, along the y axis. So sine 37 degree equal to height upon hypotenuse. So height will be equal to what? Hypotenuse times sine 37 degree. So this vector, it is parallel in y direction. So we can say 537 is along y axis. So what will be the component of this vector 5? So we can write here, if the known, you have to find out the summation of this resultant vector 5 vector 3 5 3 and 2. So we can take a vector. It means 5 has got two components. One, this is 5 cos 37, and second component 5 j 37 degree. So 5 cos 37 degree and plus j 5 sine 37 degree. Ij component you have calculated. Now this is the turn of 3m, but 3m is going in along parallel to the x-axis. It means I component. So it has got only one component, and that component is only along x-axis, not on y-axis. Y-axis it has got 0 component. So we can write only 3i. So this 3i is representing 1. So what will be its y component? J component. The j component will be equal to 0. So now this j 2m. So 2m is going 2 meter vector is going in along y direction, but it does not have any component on x-axis. So x-axis 0, but along y-axis it has got 2 ohm. So this is 2j, right? So not 2 ohm, 2 meter. So this is 2j. So what we are getting for first vector, we are getting 5 cos 37 degree I and plus j 5 sine 37 degree. Second vector you are getting 3i vector only, and third vector you are getting only y component, and that is 2j. That's a 2j. It does not have any x component. Fine. So now I and j, you are separating I and j, you are getting this value. So cos 37 degree is equal to 0.8 and sine 37 is equal to 0.6 degree. This is the angle of sine and cosine. So you are substituting the value, you are getting the vector a vector. So now the a vector is 7i and plus 5j, right? 7i plus 5j, right? So you can get it corrected here, 7i and 5j. So this will be 7i, this is 7, and this will be 5j. So what will be 5j and 7i, right? So this is 7i and plus 5j. So 7 on x-axis, 5j on y-axis. So what we are getting, tan theta equal to y by x, y component upon x component. So y 5 and x is 7. So this is the magnitude. And what will be the magnitude of this vector? You can get the magnitude of this vector. So magnitude, this is a vector, and this will be equal to under root 7 whole square, and that is 5 whole square. So this will be equal to 49 and plus 25. This is the magnitude, 49 plus 25. So I think this is coming out to be under root 74, under root 74. So magnitude of this vector is under root 74, right? So 74 you are getting you can write here, this is 74. 74 is the magnitude of this vector, and this is representing a vector. A has got magnitude, this had 74, right? Now I am coming on third problem, and the third problem is you are provided with now I am coming, so I am moving your camera on this portion here. This is, this you are getting, fine. This is the problem. So now what is you have to find out, this is the vector, you are given. OC is a vector, OB is a vector, and OA is a vector. There are three vectors you are getting, and what we have to find out, you have to find out the magnitude of OB and the magnitude of OC, you have to find out. And this is your vector, this is vector diagram you are provided with. This is your given condition, and you can see on the screen in your question also given on screen that sum of the vectors OA vector, OB vector and OC vector equal to 0. This is the point, this is the thing you have to give it. You have you by the question, or from your question side, you are provided with sum of the vectors. So this is the given condition, sum of the vectors is equal to OA vector plus OB vector and OC vector equal to 0. So this is the condition, and we have to use this relation. So now I am coming on again on this portion. This OC vector has got two components, one along y axis and second along z axis. So what we can write, we can write OC as, this is this x component on x axis, so we can write minus OC. OC is its magnitude, so OC vector can be written as minus OC cos 45 degree and plus OC j sine on this axis plus OC sine 45 degree j axis. So this is, so OC has got two components, minus OC by root 2 I and plus OC by root 2 j. What will be OB? OB is on x axis. So if it is on x axis, it means it has got no y component. So it will have only y component, x component, and so OB vector can be written as OB is the length and where it is going along x axis, so I vector. So OB into I vector. So what about OA? OA is on y axis, so y axis means j unit vector is indicating its direction, it is going in negative direction on y axis. So because it is on y axis, so it has got no x component. Keep in mind, because it is on y axis, so it has got no x component. So OA vector can be written as 0, it means 0 I component. So directly we can write minus 5 into j because it is going towards negative y direction, so minus 5j. So these are your vectors we are taking. This is the given condition that sum of the vectors equal to 0, so we are adding on all the vectors and this will be equal to 0. So you can see here on the board side, you can see, just look at this portion, you can see here sum of the vectors. It means from after resolving from this portion, 5j, OB, j, and this is OC, I and j component. If you are separating I and j component, you are getting here 0. So 0 can be written as 0 into I unit vector plus 0 into j unit vector. So we are equating, these are two equal vectors, so equating x I component and j component. So if I component we are taking, so OB minus OC equal to 0. OB minus OC, this is OB minus OC, this is equal to 0. So OB minus OC equal to 0, right? And this OC by root 2 minus 5, OC by root 2 minus 5 is equal to 0. So this is again going to 0. So what we are getting here, OC is equal to 5 root 2, and here we are getting OB is equal to 5 root 2, right? So OB we are getting 5, OB we are getting 5, and OC we are getting 5 root 2. 5 root 2 value we are substituting here, so we are getting 5. So these are the magnitude of OB and OC. So this is the way we can solve the problem. This is the way we can solve the problem. So all the three problems I have solved, and now it's your turn to solve other problems, and that problems I am giving you on the screen, right? Thank you very much.